Hello everyone. In this video I am going to explain you to solve the problem on design of cylinder and cylinder head. So let us see the problem. So this is a problem. So design a cylinder head and studs for 4-stroke engine with following specifications. Cylinder bore is given, so it is 150 mm, it is capital D value. Next is maximum gas pressure, Pmax is given 3.2 Newton per mm square. Reboring allowance, it is C value is given, it is equal to 4 mm. Cylinder head thickness constant, it is K1. K1 is equal to 0.35, and here allowable tensile stresses are given for different parts. For cylinder liner, it is made up of the alloy cast iron, so its allowable stress is 40 Newton per mm square. Cylinder head, it is made up of same material and its allowable stress is 40, same. Next, studs are made up of different material. It is made up of alloy steel, so its allowable stress is 70 Newton per mm square. So here values are given directly, allowable stresses. Okay. So let us solve this problem. So first you need to write the given data. D, capital D, bore diameter is 150 mm. Pmax, maximum pressure is 3.2 Newton per mm square. Reboring allowance, C is equal to 4 mm, and constant K1 is equal to 0.35. First, let us find the thickness of the cylinder wall. Thickness of the cylinder wall is given by the formula T is equal to Pmax into D by 2 into sigma C, sigma suffix C it is. Okay, so you have to write sigma suffix C plus C. So Pmax value is 3.2, D value is 150, sigma C. So it is cylinder wall. So its allowable stress is 40 is given in the problem. So substitute sigma C is 40 plus C constant, it is 4 mm. Substitute all the values, so you will get T is equal to 10 mm. So thickness of the cylinder wall is T is equal to 10 mm. Next is cylinder flange thickness. So cylinder flange thickness formula is given by TF is equal to 1.2 T to 1.4 T. Normally we take the TF is equal to 1.3 times the T. So it is 13 mm. T substitute value of T is 10 mm. So you will get the value of TF is equal to 13 mm. Next is cylinder head thickness. TH is equal to, formula is given by TH is equal to K1 into D square root of Pmax by sigma C. So K1 value is 0.35, D is 150, Pmax is 3.2, sigma C. So for cylinder head, allowable stress given is, in the problem for cylinder head, allowable stress value is 40. So substitute sigma C as a 40. So then you get the value is TH is equal to 14.8 mm. So you can take it as a 15 mm. Next is studs. So first we need to find the number of studs. So it is denoted by Z. In some of the books it is denoted by capital N. Okay. So Z number of studs is given by D by 100 plus 4 to D by 50 plus 4. So if you substitute D value, D means it is bore diameter. It is value given is 150. So if you calculate this, you will get 5.5. If you calculate this, you will get 7. So whatever the number of studs, so that should be between 5.5 to 7. So normally we should need to take in between value, so that also it should be whole number because it is the number of studs. So here we can take it as a 6, z is equal to 6. Nominal diameter of studs. Nominal diameter of studs is given by the formula dc is equal to d into square root of p max by z into sigma t. So d is bore diameter, it is 150, p max is 3.2, z is number of studs, it is 6, sigma t is allowable stress for studs. In problem, allowable stress for studs given is 70 Newton per mm square. So that's why, so if you substitute all the values, so you will get the dc equal to 13 mm. And this is the core diameter or mean diameter. Next, nominal diameter is given by dc by 0.8, so you will get it is a 16.25 mm. Next is pitch of the studs. First let us find the pitch circle diameter of studs. Pitch circle diameter of studs is given by d plus 3d. So if you substitute values, d is 150, small d is 16.25, so you will get the value is 199 mm. Next is pitch of the studs. Pitch of the studs is given by pi dp by z. So dp value is 199, z is 6. So if you substitute values, so you will get the pitch of the studs is 104 mm. Next is range of pitch of the studs. So pitch of the studs should be in this range from 19 square root of d to the 28.5 square root of d. So d value here it is 16.25 mm. So if you substitute these values, so range of the pitch should be lies between 76.59 mm to 114.8 mm. So actually what we have got value is 104 mm. So that's why it lies between these two. So that's why pitch of the studs is satisfactory. Next is outside diameter of flange or cylinder's edge. It is given by d naught is equal to dp plus 2d plus 12. So if you substitute all the values, so this is pitch diameter, pitch circle diameter of studs. This is nominal diameter, small d means nominal diameter, plus 12. So if you substitute all the values, so you will get the 243.5 mm. Next is stroke and length of cylinder. Stroke L is equal to 1.5 times d. So d is 150. So if you substitute, stroke will be equal to 225 mm. Next is length of the cylinder. Length of the cylinder is equal to 1.15 times the stroke length. So stroke length is 225. So if you substitute L is equal to small l is equal to 225. So length of the cylinder will be 258.75 mm. Next is stresses induced in cylinders. So we have to check the whatever the stresses induced, whether they are within allowable limit or not. First is sigma c, p max by 2t, p max into d by 2 times t, p max is 3.2, d is 150, t is 10. So if you substitute, sigma c will be 24 MPa. Sigma L, longitudinal stress, it is p max into d by 4t. If you substitute all the values, so sigma L is equal to 12 MPa. Next is radial stress, it is equal to minus p max minus 3.2 Newton per mm square. So here we need to find the resultant stress. Resultant stress is given by sigma c minus mu into bracket sigma L plus sigma r. So mu is coefficient of Poisson's ratio. Sigma c value is 24. Mu, let us consider it is 0.25. Sigma L it is 12. It is 12. Sigma r it is minus 3.2. So if you substitute all the values, so resultant stress is equal to 22 Newton per mm square. So which is less than the Allowable stress. Allowable stress for the cylinder is 40 Newton per mm square. So it is resultant stress is 22. So that's why it is much safer. So this is the problem on the design of cylinder and cylinder head. Normally this type of problem will be asked for 10 marks, 10 to 12 marks in the end semester exams. So you also solve some more problems from the previous question papers. So if you have any doubts, so you can get back to me. Okay, thank you.